Currently, we're working in and finishing Roll Tide today and tomorrow. We'll move into eclipses, modeling eclipses this week, and then prep for your SEM unit test most of next week. Yeah, you still have your unit test. Unit test will be done by a Google form on March 30th. I will explain the format as we get closer. All right. For today, we are completing the DNA and watching this video to review answers for the explain section of Roll Tide, and then doing the extend section independently. If you have questions, use email and Remind. Join Remind if you haven't done so already by downloading the app and then using the code at ASFMSSCI, ASFMSSCI. Okay, that would be the best way to quickly get a question across. So in Roll Tide, we've done the Explore section. You have gone to NOAA's website and you looked up tidal data for Watch Hill, Rhode Island. This is just for today. You need to change this to February 1st and 29th. Set the dates, plot calendar right here, and then you'll have a whole month's worth of tidal data from the previous month. Okay? You screenshotted this and then you placed it in your answer for number 1. The second question was looking at the time difference between the tides. So then looking at the crests being high tide, the troughs being low tide, there are times if you hover over the website version. Okay, so on February 5th, the first high tide was at 4:42 a.m. If you can kind of see, zoom in a little bit. Low tide was 11:55 a.m. Then the next high tide was at 5:16 p.m. And then the last low tide, the last tide of the day, was right before midnight at 11:20. Okay, so there are 4 tides throughout a day. Almost 4 tides. The 6th kind of lost the tide to midnight. Okay, they alternate from high to low, back to high to low, or you can view it as low to high, low to high. All right, it is a wave pattern. The crests are high tide, the troughs are low tide. Tides are just the difference in sea level on a day-to-day basis. It is not climate change, rise in sea level or drop in sea level. All right, so to go from one crest to one trough, to go from one high tide to the next tide, the next low tide, is going to take about, right here, 6 hours. The third one, how long does it take to go from one tide to the same tide? So instead of going from high tide to low tide, how long does it take to go from high tide to high tide? Well, if it takes 6 hours to go down to low tide and then 6 hours to come up to high tide again, then it's going to take 12 hours to go from the same tides. All right? So that's just a little bit of review. The explain section that you should have already have answered. The first question there, number 4, what is Earth doing every 24 hours? It's rotating. How do you know? Because we have a cycle of day and night. At some point, the Earth is facing the sun. At another point, the Earth is facing away from the sun. Okay, facing the sun is daytime. Facing away from the sun is nighttime. In the own Earth's shadow is nighttime. Okay, you can just time day and night. If you add up the amount of day, add up the amount of night, you should get 24 hours. All right, tomorrow or on the 19th, you will have equal 12 and 12. All right. Google lunar calendar for the current month. Look for correlations, positive relationships between a phase and tidal height. Compare full moon tidal heights with the first quarter tidal heights. All right. So we have our tide. We'll keep that there. Lunar calendar. Make sure you search that in quotes. Makes it a little more specific. Enter. Go to images, and you find somewhat accurate, reliable source. Not many places are going to lie about the phases. So lunar calendar, February 2020, moon phases, fine. Get rid of our cookies. Okay. So with this calendar, we can now then look for correlations with the tides. Okay. We have waxing happening from before the start of February to the full moon around the 16th. And then we are waning for the rest of the month. New moon later in the month, and then we start waxing again to the waxing crescent at the end of the month. All right. So how does it compare with our tides? Well, now instead of looking at the wavelength from crest to crest, trough to trough, or the period from crest to trough or trough to crest, we want to look at the amplitude. Amplitude is how high the wave can go. So where are our highest high tides and where are our lowest low tides? Okay, part of this diagram has tidal patterns that are more extreme right through here, right through the week of like the 9th to the 15th. And then they have periods where the tides are a little more minimal. High tide isn't very high, low tide isn't very low. It's very close together. And that's happening from the 1st up until almost the 5th. All right? So there's an oscillation going on, and it kind of repeats minimal, and then it starts getting extreme again around the 21st into the 27th. Okay? So how does that correlate? What kind of positive relationship can we find? If tide is getting more extreme, what's happening with the moon's phases? So as tides are getting more extreme, so the 9th to the 15th, look at this week right here. 9th to the 15th, and a little bit prior to that. The tides are most extreme when we have the brightest phases, from the waxing gibbous to full to waning gibbous. All right. The tides are a little less extreme. So again, we look back at the tides right through here, like the 19th to the 25th, 26th, and that's when we are moving away. We are in the quarter phases going towards the new moon. And then they start getting extreme again with the new moon. So at first, it's easy to say that, looking for a positive relationship, that the tidal height, so the tides are more extreme when the moon is waxing to its fullest extent. But the opposite of that is true too. The tides are most extreme when the moon is at its most minimal. So full moon versus first quarter, tides appear to be more extreme in level during full moon and new moon. During the quarters, the tides appear to be more minimal. So there's not much of a change compared to the rest of the month. There's still a change, but not compared to like the rest of the month. So the 4th versus the 11th. Clear difference there in terms of the extreme versus minimal. All right. Even very minimal right there, where we had our first quarter on the 1st of February. Very minimal. So minimal tides correlate with quarters, extreme tides correlate with the ends of the phases, full moon, new moon. All right. How long would it take for a location on the Earth to face the moon and then not face the moon in the opposite direction? So I diagrammed this on the board to help you before we left for break. And thinking about this is if the moon's directly overhead you at night, it's the full moon, it's midnight, it's directly above you, it's like noon for the moon, then how long would it take to not face the moon? So you would have to rotate halfway around the Earth. So the Earth would have to rotate halfway. Well, how long does it take the Earth to rotate? 24 hours. Well, what's half of 24? It's 12. So it would take 12 hours for you to face the moon and then not face the moon. Okay? Which is kind of interesting because where else do we see 12 hours? Right here. How long does it take to transition from high tide to high tide? Okay? 7. In the duration for the location of the Earth to face the moon and then turn away from it, how long would it take for the Earth to rotate halfway between? So basically, that question's a little wordy. I'd probably rewrite it if I could do it now. And then I would say, how long would it take for the Earth to do 1/4 turn? Okay, 1/4 turn. So you face the moon and then you turn away from it, only halfway through that. Well, how long does it take for the Earth to do 1/4 turn? 24 hours divided by 4, 6. Which is also interesting because it takes 6 hours to go from high tide to low tide, or low tide to high tide, however you want to view it. All right. So these two questions are trying to help you understand that it's the Earth's rotation and the position of the moon that's going to relate to our tides. All right. 8. What tide would you experience if at Watch Hill you're facing out towards the moon in its orbit, but not just being able to view it? So what tide would you have if you were facing the moon? Well, the moon, through its gravity, is going to be pulling on the water, the surface that you're at, better than the land, and so you'll experience a high tide. Okay. What tide would you experience on the opposite side? Well, if it takes 12 hours to go from high tide to high tide, and then you rotated halfway from night to day or day to night, then you would also have high tide. Okay? So the moon, the side that you face, that is high tide. When you turn away from the moon, that is also high tide. That's just based on looking at the relationship, the data. All right? And then the same goes for low tide, 12 and 12. 1/4 turn, you have a new tide, 6 hours. We're going to diagram this tomorrow to kind of help you understand, but hopefully you're starting to see the pattern. You don't have to fully understand when the moon creates what tide, but I just want you to start to get the idea that there's a pattern. Okay? The extend section is what you're working on the rest of today. It's 2 questions. You can use your calendar that you already found for number 10, find an image of a lunar calendar, and then you are starting to explain those relationships a little more in detail from up here. All right. So, like I said, you're trying to identify the relationship. I want you to explain it a little further here. Extend your thinking. All right. And then we'll fully evaluate how the moon creates the tides. Tides appear to occur cyclically. 6 hours transpire between the changing of tides, and 12 hours transpire between the same tides. Okay, so 6 hours to go from high tide to low tide, or low tide to high tide, 12 hours to go between the same tides. If the moon is relatively stationary, and I mean just day by day, it's only moving a small amount in its revolution around the Earth, then the Earth will alternate facing the moon and away from the moon, or also be at a 90-degree angle. So we're talking new moon, full moon, first quarter, third quarter. In rough, what we're talking about in terms of angle, all right? Being able to pick out extreme tides and minimal tides. Each of these quarter turns of the Earth will take 6 hours and appear to correlate with the positioning of the moon relative to the location on Earth. Further research is necessary using Google looking for a lunar calendar for the month of November. That's a typo. That should be February. Okay? So you're going to pull in your calendar, paste it in, and then further explain what correlations. All right? Tomorrow we'll diagram the tides, give you a better understanding, a visual understanding, and then we'll complete this evaluate and finish roll tide, which will then bring us to eclipses, the last phenomenon in this unit. All right. If you have any questions, reach out to me by email or through Remind. I'm looking into other ways to communicate with you, or you to communicate with me. I tried looking at the Discord. Um, check it out if you can use it on your Chromebook, not the app, but go to the website, see if I can use that with you. I already set up server. Don't know if it's usable on your Chromebooks or not. Might still be blocked. Also, maybe start having some Twitch sessions. So stream myself. You can jump into chat, ask questions, and I'll address your answers. All right. See you later.